Hello, so today we're going to be talking about index laws. Now, index laws are quite an important part of maths because they allow us to simplify lots of algebraic expressions, so it's important to be comfortable with how to use them. Now, there are four main kind of rules you need to know about. So the first one is where we have a base raised to a power multiplied by that same base raised to a different power. So we could have something like x squared multiplied by x cubed. So the way we can simplify this is that we simply add the two powers together, so we'd be left with x to the a plus b. We can apply a similar rule, of course, if we're dividing. So if we had x to the a divided by x to the b, instead of adding them together, what we can do is we can take the power of the denominator from the power of the numerator. So we'd get x to the a minus b. Now with these two, it's very important to note that we have to take care that the base is always the same. So if we had x to the a multiplied by y to the b, for example, where x and y were different numbers, we couldn't let this be equal to xy to the a plus b. So whatever base or whatever thing we're raising to the power, they both have to be the same in order to apply these multiplication and division rules. Now the third rule is where we have again a term raised to the power, but then we have that entire thing raised to a different power. So this might be something like x cubed all squared. And in this case, what we do is we can multiply the powers, so we'd get x to the a b. And of course, if we had this x cubed all squared, we'd get x to the 6. And then the final thing is where we have two different numbers or variables like x, y, for example, where these two are multiplied together inside the bracket, all raised to a single power. And in this case, we raise each of the terms multiplied inside the bracket to that power, so we'd get x to the a, y to the a. And the same also applies if you have some kind of constant. So if you had 2x all cubed, we'd do 2 cubed multiplied by x cubed, which of course is going to be 8x cubed. Okay, so I just want to finish with a bit of a harder example. So in this case, we have 4x to the power of 5 minus x to the power of 5, all divided by x cubed, and then that whole thing squared. So how do we approach something like this? Well, the first step I'd take is we can simplify this numerator, can't we? So 4x to the power of 5 minus x to the power of 5, because they're both in terms of x to the power of 5, we can just take one from the other. So we're left with 3x to the power of 5, all divided by x cubed, and again all squared. Now what would we do here? So in this case, we've got two things in terms of the same base, so they're both x raised to the power of something, and they're divided. So in this case, we can use that division rule, so we get 3x, and then we can do the 5 minus the 3, because the 5's on the numerator, the 3's on the denominator, all squared. So that's going to be 3x squared all squared. Now what can we do here? Well, this is kind of a combination of two rules, isn't it? So we've got two things multiplied, haven't we? This 3 and this x squared, all squared. So we have to apply that rule and square each of them separately. So we'd get 3 squared multiplied by x squared, all squared. So we're going to get 9 lots of x squared, all squared. And then remember here, when we have something raised to the power, and then that whole thing raised to another power would get 9 times x, and then 2 multiplied by 2, or 9 times x to the 4.